Hello everyone, welcome to my class. Today, I'm going to talk about interprocess communication. Interprocess communication. In this lecture, we will learn some mechanisms that process can communicate with one another and synchronize their actions. IPC means interprocess communication. As you know, interprocess means between processes, and communication means exchanging data between source and destination. So, interprocess communication means the mechanisms concerned with exchanging data between source process and destination process. Normally, the mechanisms for the interprocess communication are divided into three categories: communication, synchronization, and signals. Once again, communication, synchronization, and signals. Here, this one, synchronization. This is a little bit a difficult word, right? Synchronization means two bodies or two objects are doing something together at the same time. Okay, next, signals. We have already learned the signals in more details in the previous lectures. Actually, we know that the signals are used as a communication or synchronization technique. Okay, first one, communication. Communication mechanism allows processes to exchange data with one another. We can divide the communication mechanisms into two categories. One is data transfer and the other is shared memory. Data transfer and shared memory. Data transfer means one process writes data to the space and another process reads the data from the space. The space can be a virtual memory or can be a buffer. Okay? Next, shared memory. Shared memory allows processes to exchange information by placing it in the shared space. This mechanism can provide very fast communication because communication does not require system calls or data transfer between user memory and kernel memory. That is to say, writing data to the space and reading the data from the space are time consuming, as you know. There is no time consuming in this shared memory. So, the shared memory mechanisms provide very fast communication. Okay, let's see the data transfer mechanisms in more details. This picture shows that process A writes data to the buffer in the kernel, and process B reads the data from the kernel buffer. We can transfer the data using two methods. One is byte stream, the other is message. Byte stream means the format of the data is the undelimited byte stream. Undelimited byte stream. Normally, byte stream is a long sequence of bytes, like a file. On the other hand, message means the format of the data is delimited form. We can say this form a message. Pipes, Fifos, and stream sockets can transfer the data by using the byte stream method. On the other hand, message queues and data socket can transfer the data by using the message method. Okay, first one, the pipe. Pipe are the oldest byte stream method of interprocess communication on the Unix or Linux system. Let's see this sentence. In the prompt, ls vertical bar wc -l. In here, the vertical bar means pipe. When this sentence is executed, the shell creates two processes, ls and wc. ls command write the data to the pipe by using its standard output, that is file descriptor 1. wc command read the data from the pipe by using its standard input, that is file descriptor 0. Actually, a pipe is a buffer in kernel memory. This buffer has a maximum capacity. Once a pipe is full, the pipe is blocked. In this picture, this is a pipe that is a byte stream. Left one is source process and right one is destination process. The source process can write data to the pipe until the buffer is full. However, if a pipe is full, the pipe is blocked. So the source process cannot write the data until the destination process reads some data from the pipe. In your program, you can use the pipe system call to create a new pipe to transfer data from a source process to a destination process. Pipe system call. Next, Fifo. Fifo means first in, first out. Fifo is also a buffer. This is similar to a pipe. The different thing with a pipe is that the Fifo can be used for communication between unrelated processes. That is to say, any processes, for example, a client and server. So, we can make client-server applications using Fifo. As you can see in this picture, a client can send its request to the server using a single server Fifo. In addition, we can make multiple client and single server applications using Fifos. In your program, you can use the mkFifo function to create a new Fifo. Next, message queues. Message queues are similar to pipe or Fifo. We can use message queues to transfer messages between processes. What is a message? A message is a discrete unit of communication, like an envelope. The client and server communicate in unit of discrete messages instead of the undelimited byte stream. As you can see in this picture, message queue has separate message boundaries like this. This one is a message. Each message includes an integer type field to select messages. And message 1, message 2, message 3, like this. So we can select any messages in the queue by using the integer type field instead of reading them in the order. To create and use message queues, you can use various system calls in your program. In System 5, we can use message get, message control, message send, message receive system calls. In projects, we can use MQ open, MQ close, MQ unlink, MQ send, MQ receive, MQ set attribute, MQ get attribute, MQ notify system calls. Okay, next is socket. Socket also allows data to be exchanged between applications, either on the same computer or on different computers connected by a network. There is two domains concept. One is Unix domain and the other is Internet domain. In case of the same computer, we just say Unix domain. In case of different computers via network, we just say Internet domain. In addition, there is two types of socket. One is stream socket and the other is datagram socket. We can use stream socket if you want to transfer the data in byte stream. And if you want to transfer the data in datagram, like a message, we can use datagram socket. As you can see, there are various system calls related to socket. In stream socket system calls, we can see socket, bind, listen, accept, connect, write, read, close system calls. In datagram socket system calls, we can see socket, bind, send to, receive from, close system call. Okay, until now, we have learned various communication mechanisms: shared memory, pipe, Fifos, message queues, and sockets. Once again, shared memory, pipe, Fifos, message queues, and socket. Next is synchronization topic. Synchronization are concerned with synchronizing the actions of processes. Actually, synchronization allows processes to coordinate their actions at the same time. Once again, synchronization allows processes to coordinate their actions at the same time. For example, one process sends the data and the other process receives the data at the same time. In addition, the synchronization allows process to avoid doing things such as updating simultaneously a shared memory or the same part of a file. Without such synchronization mechanism, updating at the same time could cause an application to produce incorrect result. Unix and Linux systems provide two types of synchronization mechanisms. One is semaphore and the other is file locks. Once again, semaphore and file locks. Semaphores. A semaphore is a kernel-maintained integer. In your program, you can use a semaphore to access some shared resources exclusively. Overall procedure for using a semaphore is as follows. A process can decrease or increase the value of a semaphore. Normally, a process decrements a semaphore in order to reserve exclusive access to some shared resource. For example, the value of semaphore changes 1 to 0, and then the kernel blocks the access operation until the semaphore's value increases to 1. After completing work on the resource, the process increments the value of semaphore, and then the shared resource is released for use by some other processes. Linux system provide both System 5 semaphores and POSIX semaphores. In System 5, we can use semaphore get, semaphore control, semaphore OP, operation, system calls. In POSIX, we can use semopen, semclose, semunlink, sempost, semwait, semgetValue, seminit, semdestroy, system calls. Okay, another synchronization mechanism is file locks. File locks are used to coordinate the actions multiple processes operating on the same file. There are two types of file locks: read locks and write locks. We can also say read locks to shared locks. We can say write locks to exclusive locks. Normally, any number of processes can hold a read lock on the same file. However, when one process holds a write lock on a file, other processes are prevented from holding either read or write locks on that file. Linux system provides file locking by using flock and fcontrol system call. flock system call provides a read or write lock on the entire file. This means that we cannot operate in more details. That is to say, flock system call does not provide the fine-grained functionality. So, fcontrol system call is provided for a record locking. That means multiple read and write locks on different regions of the same file are possible. We can say the fcontrol system call provides the fine-grained functionality. Okay, in this lecture, we have learned the interprocess communication functionalities in terms of communication and synchronization. Communication mechanisms include shared memory, pipe, Fifo, message queue, and socket. Synchronization mechanisms include semaphore and file locks. Okay, that's it. Good. Thank you for watching my lecture. Have a nice day and goodbye.